Hello everyone, welcome to today's Novage webinar, Faster 3D Reverse Engineering with QuickSurface 2022. Join us to learn more about tools that improve your scan data, create a hybrid model of freeform and prismatic shapes, and even prepare the STL meshes directly for printing. QuickSurface is especially designed for 3D reverse engineering, being efficient, user-friendly, affordably priced, and with high precision. It can be used for both small and large-scale projects. Today's webinar presenter, Kostadin Vrantzaliev, is the product manager of QuickSurface and is specialized in 3D scan processing, 3D scan algorithms, and product design, and he has over 25 years of experience in the field. Kostadin, fun fact, was also a key member of the team who built the first handheld 3D laser scanner. Now, let me tell you a little bit about Novage. Novage is changing the way designers purchase 3D software, offering more choices, more freedom, best advice, faster service, and no headaches. It's really easy to shop at novage.com. Check us out. Now, without further ado, I will switch to Kostadin's screen. So it
Hello.
Yes, we can see your screen.
Yes. Thank you, Barbara, and thank you everyone for joining our webinar. Before I go in the technical presentation of our product, I'd like to spend a few minutes in a small presentation who we are, what our products are. QuickSurface and Mesh to Surface for Solidworks and for Rhino are products of our company called KBS. We have two offices, one in Sofia, Bulgaria, and the other one is in Cambridge, United Kingdom. And as Barbara said, we are a really old company with a lot of experience working with 3D scan data. We started back in '96. We participated in the first handheld scanner. We spent a lot of time with all the challenges with the scanning, what means noisy data, what means misalignment, what means inaccuracy, and so on. So we have a lot of experience with this. But our passion, we are a small team, but we have a lot of mathematicians, and our passion is reverse engineering. So that's why we created our products. One of them is the QuickSurface. So where QuickSurface stands and what it is. As you see in this picture, we try to illustrate the whole workflow and where we try to fit. So people have scanners nowadays, and they're quite popular. They capture the reality and generate surface models and representation of the real world. You know, on the other side, we have the CAD system that, to be honest, they don't really understand much about meshes. You can bring them in nowadays, you can load them, but the thing they understand purely is what we call the NURB surfaces. This is where they are the best. So our goal with QuickSurface is actually to provide tools, nice and easy and simple to use, to convert all these meshes into surfaces that are suitable for them, for your CAD system, that it can be easily understood. Before moving further, I want to tell you a bit more what we understand as reverse engineering. Nowadays, people just send us meshes and say, well, this is done. I did the reverse engineering. If I have a watertight mesh, I can just take it, put it on the 3D printer, and then I can recreate my physical world. Yes, that's true. But what about if you want to apply some modifications? As in this image, for example, you can see on the top there are 5 holes drilled. But what about if I want to make them 6? So you need to have more flexibility. Yes, you can print this, but you can print this together with all the inaccuracy of the scanners, with all the noisy information that you get. So this is what we understand of reverse engineering. Technically, this for us means that we need to convert this information into something that the CAD system understands. This would mean we have a pattern, we have a description of a cylinder, we have some dimensioning. What about if you want to change the diameter of the cylinder, and so on? The other question that we quite often come up with is what is actually the correct reverse engineering? If you see on the left side, this is a scan data that we have as an example. People bring this in and they say, I want to bring this into my cut package. Can you convert this into a NURB surface? Okay, what this means is like the image on the top one. Technically speaking, this is a NURB surface, yes. Once it's converted into this type of model, you can bring it into your cut package. But I just described here, it has 260 megabytes of size. And what you can do, you can render it probably. From my experience, probably you cannot do too much with this. You need to remodel everything. Why? Because it wraps up the surface, but I don't see a cylinder, or I don't see any parameters, or I can't change any diameter, and so on. So quite often our potential users, they just download our software, bring in a model like the one in the picture, press the auto surface button, which is one of the best on the market nowadays, and they expect miracles. Well, unfortunately, that's not true. If you want to model an object like this one, you need to spend some time to define your strategy, how you actually will build your model, how you actually will create your surfaces. And this is, I hope you can see at the bottom right, probably this is what you would expect. Well, unfortunately, as of today, our automatic surfacing cannot do what you see on the bottom right. You need to split your tasks, you need to apply strategies and how you can do this. So I'm just telling you some information so you can better understand what actually reverse engineering is. So what is the normal workflow and why we created QuickSurface? You bring in the mesh and your goal is to create a cut surface that the cut packages can fully understand. QuickSurface addresses all the tedious tasks. We try to provide tools that can minimize this work, and you can feel in a comfortable environment. And one of the advantages, and what I hear from our customers, is that we provide easy tools and we minimize the learning curve, so the users can easily do this job to get from the scan data into the cut model. So this was a very brief and short explanation what we are, what is QuickSurface, and I would like to go straight into QuickSurface and start explaining what are new features, and probably I'll cover some of the existing features as well. I'll just stop this for now and bring QuickSurface in front of you. So this is the welcome screen of QuickSurface. If you just get it installed, what we brought to the user is that when you just install the software, it's really easy. You just press on the Learn from Tutorials. We created a lot of tutorials, so we encourage the user just go there and go step by step so you can learn our software. Even if it's quite easy to use, it's still good to watch all of them one at a time. So I will start with my first example, and I'll bring one scan mesh. What we introduced in QuickSurface 2022 is the ability that you can actually support multiple meshes. In the previous version, the only mesh you can import is a single one, and you can work on this one. But now there are many applications where you actually can bring in more meshes, and you can do this just by importing a mesh. I just bring in the bottom part, and now they can live together. Later in my presentation, you'll see how important this is and what you can do with this. But just as a demonstration now, I will just do interactive alignment. I can probably move this in space. I can technically rotate this in 180 degrees. We can probably align this, put it in the correct position, just visually on the in space. And this will give me a good orientation of all the part. So if I need to do remodeling of the assembly, this will help me really a lot. So this is one of the first things that we introduced in our new version. The other thing that we, oops, I just pressed cancel, but that's okay for my next step. The other thing that we introduced is that you can actually duplicate the mesh. The reason for this is that in reality, when you scan something, it's very rarely that it's a single part. Most of the time, it can be actually an assembly. So what you have is different parts that you want to focus on. So while we need to duplicate this, I can just may want just to preserve this original mesh and go here and edit the mesh. I'll go in details about the mesh editing in a bit later in the presentation. But if I just put this in the top view, I can probably just delete some of the areas that I don't need it in our mesh editing tools. I can just get this bracket and stay focused on this area only, which I will remove. So this was the first thing that we improved in our QuickSurface to support multiple meshes. So I will move to the next example now, which is about the polygon reduction. I know you probably in your scan software, you can do some kind of polygon reduction, but some of them, they don't really do this. And you come up and you need to remodel this object. QuickSurface doesn't have any limitations in terms of the size of the object that you can bring in. You can bring in 80 million triangles, for example, but then you're limited to your RAM memory and your graphics card. Despite this, we always recommend that you actually reduce the number of triangles, not only for the visualization purposes, but for the algorithms to make them easier to work. For this reason, we introduced the reduce polygon functionality that you can just reduce the number of polygons to the based on the number of triangles that is your aim. Let's try to do this and reduce this in half. The algorithm is fast, and as you can see, it reduced the triangles, and I barely see what is the difference. Now, because we come from a methodology background, the question is, the people will come and say, why did you touch my data? You lost accuracy. Maybe this is not what I want. You probably moved something in space. Well, for this reason, we have something which is called analysis that I can turn on and see how much my original mesh deviates from original data that I started with. I can always see the mesh wireframe, and you can see this is my original data, how poorly the triangles are, and then I can see the next step, what it will look like. So in this example, you can see that even I decimated the mesh 50%, I still have all the points 100% within 5 microns. So it's better if I just go and keep the mesh lightweight, so I can do easier rendering on the screen or allow the next algorithms to work better. So I can press OK, and then the software allows me to have a choice whether I should keep the original also or just replace the existing one. In this case, I would say, no, please just keep the original mesh. I may need it in the future. So I have the 2 meshes. I can save them on the disk, save it for further use. So this was a small and nice improvement for your efficiency. The next thing which we introduce in our new version is something that it's about extracting primitives. I just bring in this example. You can find it as a standard part in our educational tutorials. So we introduced this feature, which is extract primitives mode, where you can quickly just select and adjust your slider. If you look at the tutorials, you can learn more about the features, how you select areas on the screen. But you can very quickly just create this as a plane and create it. It remains on the screen, and you can also just pick another area, create it as a plane, and so in this way, if you have a complex mechanical part, you can easily just extract the primitives. So what is interesting about this is that we also provide what we call the constraint fitting. Now, in reality, when you fit the plane or a cylinder through the scan points, they are never exact in space. For example, what I show you here, this cylinder is never perpendicular to my plane at the bottom. Why? Because there are a lot of noise due to the scan process. So this perpendicularity is not guaranteed. In this case, you can just go and choose. You can see the plane one is here, and you can tell the software that actually this cylinder is perpendicular. This helps a lot to create correct models. At any point when you extract the features, what we introduce also is our analysis tools. So you can always see, before you create your primitive, how it actually fits through the data you have selected. In this example, I see that it's actually probably the model, that it's not exactly a cylinder, but this is the design intent, what you want to do. So you actually can carry on and create this cylinder. For those who are new in QuickSurface, why I created these 3 primitives very quickly is because we may want to align this into the correct position in space. This is actually the first thing you need to do when you start your reverse engineering. For this reason, QuickSurface supplies something which is called Align by Coordinate System. And I can easily just pick this as my z-axis. In this case, I need to flip it so the z-axis is up. Then I tell at the bottom that this is XY location, and then I pick this. I need to flip the orientation to Y, and I see that my coordinate system is fully defined. I can just apply this, and if I look, everything is correctly applied. So this is our new thing that you can very quickly create new primitives in a very intuitive way. I will just want to bring another feature in our software that we introduced. Excuse me. So we have pre-aligned this part, and I show you the coordinate system and see how it is well aligned. So let's go back and start extracting our primitives. In this case, I just create a plane. But here is the difference between the metrology and reverse engineering. When you do reverse engineering, you want at the end your part to be manufacturable. What this means is that I want this plane to be absolutely perfectly parallel to my bottom coordinate system. I don't want to have any tilts, because then the machine, if I export this, will not be able to manufacture this. For this reason, if, as you saw in my previous demonstration, you can constrain this. But we introduced something which is the smarter way, which we call auto-constraint option here. I'll go through a bit in details what this means. How it works when you fit a plane or any primitives, it just takes the orientation of the plane or the axis of the cylinder or the axis of the cone and tries to compare with all the features that you already have in your scene. In this case, if the tilting tolerance is less than 0.5 degrees, so if this plane is very close to be parallel, it automatically will tell the software to constrain this, so when it fits the plane to be absolutely parallel to my bottom. So this ensures me that I will get the correct plane. Let's try to emphasize what I mean with this. I will just select this plane and say create a plane. If we analyze, you may see now that this is a blue area and this is an orange one. Why? Because the software did its best to fit this plane and keep it absolutely parallel to the bottom. Sorry. Because it's auto-constrained, now we're sure that it's parallel to the bottom, but it's not the best fit. If I turn off the auto-constraint, you see that everything is green. So it's up to you to decide now, what is the design intent, how you want to carry on. So this auto-constraint smart feature helps you very quickly to extract the primitives. And to finalize this new feature, I will just extract this cylinder. As you can see, it just found that this is parallel to the z-axis and created this as it is. So this was our new features of very quickly to extract the primitives for the purposes of alignment or very quickly to generate models. I will move on to our next feature, which is called Endpoints Align. I'm bringing in the object, which we just went through, and it's a basic part you can download from our tutorial page. There are many cases when people actually have a cut model, something which has been designed already. I will bring in the cut, like this one. But the real object has been modified. So what is the goal now? What we want to do is to actually modify our existing cut model like the one we have in the reality. So thinking logically, the way I need to do this is to bring this next to my cut model and then just apply the modifications. I see that there is something else here created in my real object which doesn't exist on the cut model. So what we need to do now is actually to bring this next to the cut model. Let's try to do this. I'll just select my mesh and we'll go to do it interactively. I'll place this on top, and then we can use the manipulator and probably just try to rotate and 90 degrees or maybe another 90 degrees, and you can try to do this manually. Well, this is not the right way to do this because this is inaccurate. Whatever you do, I doubt you manage to do this precisely. Here is a hint that I normally recommend of how easily we can do this in our QuickSurface. I'll put this in top view, and I just look how my cut model looks like, and I'll just hide it because I don't need it for now. I'll try to do with just a simple mouse move and place the object roughly in the same orientation that my cut model looks like, and then I will say use as a current view. What the software does, it transforms the model so it was in the center, but the Z orientation and the X and Y is the same like I placed in the view. I turn on the cut model, and as you can see, they are roughly in the same orientation. I'm not trying to put them together, I just put them on the side so I can see them quite well separately, but with the same kind of view. And that's all I did for now. What I need to do next is I will use something which is called Align by Endpoints. And as you probably guess, the endpoints means that we have several points that we can pick from the two objects, and they will align. So let's try to do this. I'll just pick point 1 and point 1 here. So the way it works, you need to pick the same number of points on the two objects, and they need to match. I mean, if I pick this point here, I need to pick the same point on the scan data roughly in the same position. It doesn't need to be accurate because it's hardly for you to tell which one is where. And then you need minimum 3 of them, of course, and then you can press preview. So what the software will do, will align the scan data to the cut model, to your reference, using these 3 points. But as you can see, it didn't went well. And there is a reason for this. I did this on purpose. The problem is that we placed our points quite in a straight line, which is not good for the mathematics to align the two objects. You can always press reset, which means it brings back the object into the original position. And you can pick other points, like point number 4, point number 5, and another point here. So this is a trivial approach of using a number of points. You're not limited to 3 points only. You can pick as many points as you want, and then you can just align them. So as you can see now, we just managed to place them together. When I'm done, you can always press compare and see your results. I can clear the labels from my previous try. What is wrong here is that it's actually, I pressed 0.5, but I didn't get any closer. So what I need to do is something that it's called in the industry like fine align, and we have this functionality. The fine align works with the search distance, and before I carry on, I want to explain a little bit about this, what this search tolerance is. For this reason, I will just create quickly a 2D sketch here, and I'll explain visually what this means. When this fine align works, it uses this search distance to use the white points to get it as close as possible to the surface of the cut model. But because these points here, for example, they don't exist in the original cut model, they will be taken into account. So it's not a good idea. And fine align will try to move everything and to balance the minimum error, and you will not actually get what you need. So if you have a roughly aligned object like this one, I'll delete the sketch, I don't need it anymore. It's recommended that you use a smaller values, like for example 0.5 millimeters, and then you run the software. So I will compare here, and you see how better I got to the cut model. Well, but still, I'm not really happy with what I got. And the reason for this is that in reality, when you manufacture a real part, it's never the same like the cut model. When you do machining, some of the surfaces are created much, much better than the others. In this case, I trust these two planes much more than everything else. So how QuickSurface handles this, I will use mesh editing tool only for the purposes of selection. I'll just the magic one. We'll pick these two planes as a selection and we'll close. Now I will just go back and we'll apply the same fine alignment. In this case, I can just leave this to a really high value because all these points that I selected are actually mapped to the cut surfaces. And in this case, the software will use only the selected points to apply the alignment. Let's see the compare functionality, and everything is so well, it's very well aligned to the surfaces that I pre-select. So this was about an alignment when you want to try to align the surface, the scan data to the cut model. But let's carry on and finish off our remodel our initial cut here. What I will do, I'll just go to extract primitives, will unselect all and pick my cylinder. This will fit the cylinder through the selected points. But if you see that our auto constraint is on, what it found is that it's quite close to the z-axis. So technically speaking, the cylinder that has been detected, now it's perfectly defined along the z-axis, and it uses this coincidence tolerance to make this matching. And I'm happy with this, and I will create. Then I can also create my plane. Again, it's parallel to the bottom, which is perfectly fine. And I will just do our simple tools to create a solid with this. How we do this, I just pick this plane and the cylinder, use the trim operation, oops, control to select two of them, and then you pick the icon, remove unnecessary, and press OK. Now it's open. Actually, it's not a solid. The good thing about parametric modeling is that I can just edit the cylinder and then make it solid. Now we have a solid. I can pick my cut file and use the Boolean operations to get rid of this. So let me finish this area that we want to create here. I will just right click and hide everything. Again, we'll go to extract the primitives. Why? Because I need this plane. It's again perpendicular to the bottom. It just gives us guidance and keeps us on track for our design intent. Now I will use this plane to create my sketch here. And here is our new feature that I want to introduce, which we have in the QuickSurface 2022, is that when you create a slice, now there is an option here which you can turn off. So what actually this means is that when you create a slice, it will make the slice, but it will project the slice on where you started your sketch. This is quite useful, and this is another new feature that you can find in QuickSurface. I will create the sketch now, and very quickly we'll hide the data. I don't need this. I don't need the plane. I will use our quick tools with the shift mouse button to fit these two lines. We'll create a line because all I need to do is just create this bigger than my original object, so I can use the cut operations. And we'll use Control and Paint just to trim these. And the last thing I need to do is just create my tangent arc here. So you see how easy it is. You can just move. Of course, you can always turn the tolerance mode and see how close you are to your references. And then you can press OK. I'm almost there. Selected the sketch. It created my extruded surface. Let's see what we have done so far. And to finish our remodeling, I will just cut from this selected model and I'm done. Let's see the scan data. As I said, you can always press the compare button. This is a basic compare functionality that you can use if you bring in scan data, if you align it to the scan data. You can just pick some labels here. And then if you want to send this to your customer to report the accuracy of your work, you can always just select analysis and snap this to the clipboard. What it does, it just create a new image, which you can put in Word or Excel, and you can create reports and so on. And this will help you a lot to create really accurate results. Another thing about using the Endpoints Align is actually that you can use it if you bring in some parts that have been scanned in different positions and you want to put them together. So I brought in an example that has been scanned of the two meshes. I just want to demonstrate this, that it's not limited only to scan to cut alignment, but you can use this between two meshes. So what you need to do is just select your active mesh and then you go to align using the endpoints. Let me pick 3 points of the reference mesh, and then I can pick 3 points on my active mesh. Yeah, nicely. This example is with the target, so I can easily see where they have been. As I mentioned, it's good if you put the points parsed in space, so they are not aligned in a single line to get the best results. Let's take preview. The software automatically will optimize after that. So yeah, you got these two meshes aligned, and then you can probably just create a section and carry on and do your model. So I would like to move to our next new features about the meshes. This was also quite a big development in our software, which is new in QuickSurface 2022. It's all about the meshes now. Some people bring in and they want to slightly modify the meshes. They look, I put this intentionally so you can see the problems of the scanning industry. It's an old scan from 90s, but you can see that there are misplacements. People might want to remove some outliers. And for this reason, we introduced our mesh editing tools. Let's select this mesh and go and try to edit. We have a lot of selection tools that the people can actually manually just brush on top of the mesh. And you get a quick dialog. What you can do with this, I can quickly just remove some of the triangles. I can just probably paint these over and reduce the noise. So you can apply smoothing, and you can also invert the selection. It's just the standard tools, basic tools which you can apply with a. So, but what else you can do? I brought this on purpose. Let me unselect everything. We have two very important features that we have in our software here, which I want to emphasize. One is called individual meshes, and the other one is holes. When you bring in a mesh, even if you see it on the screen, it's hardly for you to judge whether it's watertight or not. Individual meshes means that how many small disconnected meshes you have actually. In this case, I see 12. I don't see them, me personally, on the screen, but the software detected them. And also, there are a lot of holes. So when you have a sheet metal, for example, or something that is open as a surface, your goal is to have only one hole, which will be the boundary, and have no other holes. Or if you have a mesh as a solid, which you need to print, you need to have 0 holes. So these tools will help you a lot to do this. Let's go and explore the first one, which is about the individual meshes. We have a tracking tool that you can just go through all the individual submeshes. Technically, they are colorized, and you can probably see them or maybe not. When you go through the individual meshes, you have to be careful not to delete something which is valuable and so on. So if you track them, the software automatically gives you the size of this selected submesh. You can always just click and see the size. So what you can do is just, you can tell the software in a batch mode, remove everything that is smaller than this area. Or the other option is, I see that now I have 9. I can probably just go and try to detect the size of the submesh. But what you can do, you can actually measure physically on the screen and say, just let's try to remove everything that is less than 1 square millimeter, because obviously I don't need, this is definitely a noise. So you see, I ended up with one single mesh, and this was my goal. This is what I wanted to do. Yes, now my goal is I have a lot of holes. So the holes, they work in a similar way, like the individual meshes. Your goal is actually to eliminate all of them, and there are a lot of tools to do this. So I will just go back and open my next example that I want to go through this hole filling approach. Let's go and edit this, and I see that it's only one mesh, and I'll go and try to delete holes. So as you can see, there is a small hole here. You can just click and try to fill it. The problem is that sometimes the hole is identified like this one. So we have a feature here which is called expand the selected hole. So if something is wrong, it is really badly oriented, you can help the algorithm to enlarge this hole. And when you're happy with this, you can just fill it. In the same way, like the individual machine, you can just go in a safety way and just track and go through all the holes. As you can see now, I don't really see the hole, so you can always create the mesh rendering transparent. This is actually not a nice hole to be filled in right now. Again, you can always just select an area and say in a batch way, okay, 3 millimeters, fill all the holes of this size. And this is your way of improving and reducing the number of holes. I'll just go back and go a bit more in details. Let's try to improve this area. How I can do this, I will just delete this with the normal selection tools, and I'll try to close this. Now I go to edit the holes, and what we have is now is the fill semi-holes. How it works, you select this, you select one point of the semi-hole, select the other one, and now the software doesn't know what to fill in, so you need to make a third click and select this to be filled. In this way, you can actually fill all the semi-holes. But in some cases, the software may not be as good as you would like, and in this case, you probably need to introduce something which is called the bridging. How the bridge works, you select actually the two sides of the bridge, and the software will automatically close this. So this is the three modes that you use when you interactively fill the holes, and in such way you can improve your model. But we also introduced a quick way of doing this when in a fill holes mode. If I hold the control key, I can just temporarily turn into the fill semi-hole, and the software will fill this. If I hold the shift key, I can just click here and improve my hole. Of course, I can always have an undo button and so on. So you can play a lot and try to improve the mesh, so you can get a watertight mesh. You can actually pull and export this directly for the printing. You don't really even need to do any reverse engineering. So your goal should be to have only one mesh and have 0 holes. So this was just a demonstration of the mesh processing tools. I want to move to some more features that we have about meshes and why we need them. I'm bringing in an example which I like a lot. This part is a good example of a hybrid modeling. What we understand as a hybrid modeling is the combination of something that is purely prismatic, and we have this as an example that it's been already modeled. How it's been modeled with extrusion surfaces, trim operations. Let me just hide the mesh so you understand better. So everything that it needs to fit, you have the distance exactly. But then you have your freeform, which is not of that big importance. It's the most important where these parts are, but you want to recreate this. Let's take a look at the back surfaces, which we also have created. So what about this area? How can we approach this? And let me show you how we do this in QuickSurface. I'll just put this in a standard view, so I'll hide these features for now, and we'll construct a plane. This is just a normal plane. My goal is to place it here. And my goal will be just to get rid of all the prismatic shades, because I want to do a freeform modeling on my mesh. And for this reason, here is the good thing about the multi-mesh support. I can keep my original mesh, right-click, and I'll just duplicate. This is the mesh I'm working on. So now what I will do, I'll take my mesh and I'll go and edit. I want to introduce now what we have as a split mesh functionality. I will just go the default one, which is called the split with another body on the mesh. So what we have here is our mesh. We have pre-selected the plane. If you have other features, you can just pick the trimmer, the one that will trim the mesh. What it will do, it will just cut the mesh using this primitive. I just press preview and leave this to the algorithm to do the job. The software automatically colorizes all the meshes that they have been created. I press OK. Now what I need to do in this case, I'm interested only in this main individual mesh. We'll go and edit my individual meshes. We'll pick this one. And this is the button which I didn't cover in my previous demonstration. If I click this button, it will just get rid of everything else and will leave this, which is selected. So I'm nearly there. I will remove this plane. We'll put this in a standard view. I want to get rid of these holes. The reason is I need to model them into a parametric way, not in the freeform way. For this reason, we have a nice circular selection tool like this one, and press delete. Let's delete this area also, and press delete. So what I need to do now, I need to close them. I just press the few holes, and you see how nicely interpolated this surface. In this case, probably I may want to just to enlarge slightly the object so it can be interpolated better. And then I press the close button. So you see how well it did the job. Now I may have some areas here that it's not nice, but they look okay for me. I have 5 holes, but before I continue, I see I have 4 individual meshes. Why I have this, I just select this and leave this one on and go back. Now I have only 2 holes. So this is what I need actually to make a freeform modeling. Sometimes due to algorithmic error, you may end up with situations like this one, with the gaps. Well, so what I can do, I can just use my fill semi-hole tools, and this will automatically fill because it just discovered it's a single triangle. And this is good enough. I just explore and find my edges if they're good for well trimmed for the automatic surfacing. Yeah, they look okay for me. So now I have this surface, and now I will call our automatic surfacing that can do the job now. So this is our new approach of how to use automatic surfacing. So you need to prepare your mesh to make it more suitable for auto surfacing. If your mesh has a lot of holes or not a good boundaries, auto surfacing simple will not work. So this is what it did in less than a couple of seconds. This is my freeform surfacing. I can probably go and edit. I didn't put it in the front view. So what I need to do now, as you can see, this is my shape. I can just double click and we'll use our interpolation tool. We'll just move this up so it goes more than it's needed. This is what I did. I'll double click. I will just need to select the boundaries to take the whole boundary, and we'll extrapolate. In some cases, you may need to do some manual work, but that's the good thing about QuickSurface, that it allows you to do to go back and just improve your object the way you need, like this one. It needs more improvement, but because of the time limitations, I am not sure I can do this in the best way now. So probably I will just get this a bit more so they can intersect like this one. But this is what I need for now. I'll just close this, and we'll use our trim functionality. I have 3 parts created already, and I will just get rid of these. Get rid of these. As you can see, the software automatically created this as a solid body. Yes, this is not accurate enough, but you can go back into freeform surfacing and you can improve this and get this as close as possible to your reference mesh. Let me just edit this to see why it didn't hide. I'll just press cancel. Yes, everything is good. At any point of time, I can just press compare and you can see the result. I can go back and now, let me clear the labels. I can go back and modify my freeform surface in a way so that it gets as close as possible to my reference. For example, here I can just select. I can turn the analyzer and just try to move and improve my result. And because it's parametric, when you press OK, everything will be rebuilt and you get the result back. Let me just, yeah, you can see it rebuilds the object and it recreated the surface. Let me just edit this. Yeah. So this is how and why we created these tools for mesh editing to be able to create this hybrid type of modeling. And the last thing I want to show you in our new features is how we can use this even further. I will just bring in a mesh that has been scanned and we'll go to mesh editing. As you can see, this is a single mesh, there are no holes, and you can easily print this. You can send this to the printer. You don't even need to do any reverse engineering. It's a solid body. You can put this in any software that can print and you are ready to go. What is the problem now? That these holes don't really match of what your expectations are. So you don't really mind of the this body is strong enough to carry everything, but what is the most important is these holes. So how QuickSurface helps in this case? You can bring in import cut models or recreate your cylinders here, and I'll give you an example what we can do in our software. Let's take this cylinder here. I will just go and edit my mesh. We'll use the selection tools to get rid of this hole, which I would call it defeaturing, just to remove the actual hole. We'll go and edit and close the hole. It's possible that sometimes you get the problems of the algorithm like this one. So what we'll do, I'll just select this area and repair all of these small areas so you can get a nice and smooth result. Let's try to do this on the other side. I can probably enlarge because I try to fill flat surface here, but it actually it's not good enough. So it's a good idea if you enlarge this. Double click to close this. Again, we'll just try to get rid of all these small problems that I have. As you can see, I have 0 holes now. I'm quite well with my solid body. So I'll take this cylinder, not this one, the other one. And now I will go again to the split mesh. If you remember, I showed you how you can split the actual mesh, but what we have here, if you have two solids, I mean a solid mesh and a solid surface like this one, I just need to select this so it knows that it will work with the cylinder. You can actually apply the other operation, which is called cut. So what the software will do, we will actually apply Boolean operation between the cylinder and the mesh, and we'll create a surface that it's suitable for printing. And I pre-created this before the presentation for you to get a better idea. This is the same object with all the holes created. And the main application is that you don't need to do the full reverse engineering. You don't need to recreate all the surfaces that are quite complicated in order to print this part. You can use these Boolean operations between solids and meshes, and you can export this directly into your printing software. So in general, this is what we covered. I would like to go back to our presentation slides now. What are the benefits of QuickSurface? As you saw in my demonstration and a simple example, you can apply this on broken tools and molds. You can control your process at any point to have the best design intent. You can apply and use QuickSurface to resurface something which is handmade, for example, created by a clay. You can modify existing cut models, and you can compare somehow the something that you have scanned against your existing design. And with all these simple tools, you can speed up your time for manufacturing. And the other thing is about QuickSurface. As you can see on the screen, it's a fully parametric. It has one of the best on the market, automatic surfacing. We provide a hybrid modeling, which is the combination between the free form and the prismatic shapes, cut boring operations, and so on and so on. So this was the end of my technical presentation. Now I'd like to stop and ask you for your questions. Hello?
Hello. So we don't have any questions so far, but you know, we're gonna stick around for a few more minutes and ask away. I'm sure you've enjoyed this presentation as much as I did. Do you mind, Costa, if I show my slides while we wait for some questions? I want to remind everybody where they can find QuickSurface 2022 on Novage.com. This is the product page. You can call us, request a quote, and we can help you through the process, even combining it with other software that you may need. Yeah. So, Costa, I don't see any questions. Oh, yes.
Oh,
Wait.
I see one.
Can you quickly show how this works with Solidworks or Rhino? I don't know if it's a quick thing, but I'm going to share your screen again. So if you feel inspired.
No, okay, I will. Okay, here is do you see my screen now?
Yes.
Okay, now what we have is not, we have a core technologies underneath the technology, and we have a different product. We cannot have QuickSurface to work directly in SolidWorks. So for this reason, we developed something which is a plugin for SolidWorks. So this would mean it's a naturally integrated in SolidWorks. We've done with you, with Novage, another presentation a while ago, so you can find this. But our technology is integrated in SolidWorks. As you can see, it's loading the plugin. And the difference, the main difference is that if you have SolidWorks, this product exists in SolidWorks. So what you saw today in my presentations, some of the features we provide in SolidWorks. I cannot give you details now because it's longer information, but you can contact us or you can browse on the website. But generally, what we offer with our how to say, let me just find the presentation. QuickSurface webinars. Yeah, we did this in June, probably.
Yes, I'm going to look for the link right now.
Actually, what you can do here in SolidWorks, as you can see with our, No, it's okay. I just managed to bring this in. So you can do a lot of stuff here with our mesh to surface. You can do automatic surfacing. You can do freeform surfacing, for example, here. But what is the difference? You stay in SolidWorks. So this is a different product. If you are interested, you can work with this product in SolidWorks. It just tries in SolidWorks to overcome all the limitations that you have in SolidWorks. So this is just a simple example of our automatic surfacing. You just bring in a mesh, you press auto surface, and voila, you get something which you cannot actually do in SolidWorks in any way. I just ready, I press OK, and I'm done. And this is a SolidWorks body. Yeah.
Great. So the other question is, so does this version of QuickSurface 2022 replace the past plugins for Rhino and SolidWorks? I think
no.
Exactly.
No, my answer is no.
Yeah.
There are three different products.
3 different products. So
yes, there are 3 different products.
If you go to Novage.com, you can see the different products, and you can read the different description, and you will understand what these products do in details and the way they work. And so there's a next question. So can it be possible to use the software for repairing bad step or IGES files? What do you think about that? No.
No, my answer is no. This is not a CAD software. This is the field of repairing IGES and step is in the field of the big players like SolidWorks and AutoCAD. We are not. There are other solutions for repairing CAD files. Okay. We are mostly focused on reverse engineering when you scan something and want to make it cut.
Very clear. And we have great feedback. Awesome product. Thank you. And this attendee says, I used to use Geomagic, and this seems so much more powerful. Thank you. And can you show the freeform function?
What do you mean the freeform? I just showed it in SolidWorks.
Yeah, that was it.
If this is not a freeform, tell me what it is. I mean,
yeah,
I just pressed the button, and this scan mesh, which you see on the screen, this is coming from a scanner. It's being converted with about less than a minute while we were talking into absolutely solid.
Yeah.
That you can use it in any way, in any CAD packages.
Fantastic. Fantastic.
There are a lot of details about the freeform modeling, so I encourage you look at the web or contact us for, I don't know, a detailed demonstration with a specific part and so on. For example, this example which we put on the screen is modeled in a manual way. You can do it automatically and so on. There are so many. Also this one, this one was also a typical example of a hybrid modeling where it's really hard to remodel this area while this is a purely mechanical surfaces.
Well, we can all agree this product is amazing. Thank you so much, Costa. Again, you can go to Novage.com and find QuickSurface, Mesh to Surface, and the detailed product for Rhino and SolidWorks that are separate. You can call us and ask for all the information, and we're always here. Our phone number is on every page of our website, so it's not hard to find us or write to us. Thank you again for the awesome presentation, Kostadin. We're very much looking forward to people using this product. It seems fantastic. I want to remind everybody that I will be recording this session, so it will be up on YouTube later today. And if you want to view the webinar that Kostadin mentioned about Mesh to Surface or other webinars about QuickSurface, go on our Novage webinar series, and they're all listed. Thanks again for joining us today, Kostadin. Have a great rest of the night, and bye-bye to everybody else.
Thank you. Thank you, everyone.
Bye-bye.
Bye.